This next unit we're going to be working on is dealing with exponential functions and logarithmic functions. Now, those can both sound very intimidating the first time you hear them, but actually they're very straightforward, especially the beginning parts of them, which we're going to be working on in this unit. Now, as you move into pre-calculus, clearly this will get more advanced and a little bit more challenging, but for what you're going to do in this unit, everything is really very workable and very straightforward. It's just a matter of getting over a few hurdles here. Now, the first few lessons will be dealing with the exponential functions, and you've dealt with exponential properties before, and an exponential property has a base raised to an exponent, and so you're used to seeing something like x squared, where x represents the base and 2 represents the exponent. Well, an exponential function is a little bit different. An exponential function has a numerical base with a variable exponent. So the b represents the base of the exponential function. So we could have something like 2 to the x power. So this, if we wrote this in function form, would be an exponential function. Now, keep in mind, whatever value is being raised to the exponent, that is the base. And so we would work off of that. Now, just like any other function value, that base can have a multiple. And so you could say that we have the b to the x could be multiplied times an a value. And if you remember, our a, x, and k, our a, h, and k values for when we do transformations, that a value comes into play. Any exponential function can be either what we call a growth function or a decay function based on the value of b. So if you look here, and you can see what this would look like from a graphical standpoint, exponential growth from left to right increases exponentially, as we would call it, and an exponential decay decreases exponentially. Now, if you notice, the x-axis is an asymptote. You have experience with the end behavior using asymptotes. So if you look down here in this concept box, you'll get a quick view summary of everything regarding growth and decay functions. And so you can see that if the b value is greater than 1, we have an exponential growth. If the v value is between 0 and 1, we have exponential decay. So let's take a look at a sample problem here. Sample problem number 1. Go ahead and take a second to answer A, B, and C, and then come back and look at the solution. Okay, so if we're looking at this, we're looking for A times B to the x power. And to determine if it's an exponential growth or exponential decay, we want to look at the B value, and that's what the hint and the problem has given you. And so if you look at part A, we're going to look at the B value there. We have 2/3, and we know that it's between 0 and 1. So that is a decay function. Now the next one's a little tricky. We have 3/2, and it's in a fractional form, but that 3/2 is actually greater than 1. So since it's greater than 1, we know that that's going to be a growth function. The last one actually needs to be rewritten. We can see here that it's 10, and it's 3 to the negative x. To make that a positive x, we would make that to the 1/3 raised to the positive x value. And so now that we have 1/3 as a b, we know that that is a decay. Alright, so that should be a good quick introduction to exponential growth and exponential decay. As always, it's good to read through these notes in full, since I'm not addressing every single word that's being written in the notes. In the next video, we'll talk about graphing exponential growth and decay functions. Now we'll take a quick look at some graphing exponential growth and decay functions. Now, as always, at this point in the year, we're really just kind of making sure we can identify the graph with a given equation. However, if you were to graph these by hand, a t-chart is our normal mode of operation. Now keep in mind here that the a value in this particular function is actually 1. So 2 is the base, and you can just do a simple t-chart to come up with a given graph. And we know that the y, the x-axis, y equals to 0, is an asymptote. So A couple things here. You would definitely want to use numbers that would, integer values that would probably make it easier to graph this. As you get going positive and negative, that'll make graphing these a lot easier. Every now and then you'll end up with a fractional point, but it shouldn't be too bad from time to time. And since you know the basic shape determined by the asymptote, plotting a y-intercept and one additional point may be all that's necessary. So if you go ahead and take a look at the next sample problem here, go ahead and graph these two sample problems and come back and take a look at the solution. Alright, so for this first one, I'm just going to graph a couple t-chart points just to have a generic idea of what this looks like. And the first thing I really want to know is when x is 0, what my y-intercept is. And if you keep in mind, anything to the 0 power is just 1. So that makes 2/3 right there my y-intercept. So 0, 2/3, and of course you just graph that as best you can. And then I'll do one more and try to come up with a decent point. So I'll do 2. So if I do 2 to the second power, I get 4. 4 times 2 gives me 8. So that gives me a point of 8/3. And 8/3 is a little bit more than 2. So I'm going to say 2 and 8/3 is about right there. And that's plenty good enough. And because I know that this is going to be an exponential growth function due to that 2, so I know that that's growth, I know that I'm going to have an asymptote here, and then it's going to build up from there. And so that's a pretty good representation of this particular graph. If I look at sample problem 2, I now know that I'm dealing with decay because it's a fraction, and then if you recall from the last problem, that a value was actually our y-intercept. So that makes this process of graphing a point much easier. So now that I've done that, I'll actually just kind of do one more point here. I've done the 0, which I know gives me 4. I'll just do a positive 1. If I did a positive 1, that's actually going to lead you to 8/5. Not quite 2, but a little more than 1. And we know that this is coming from up here, and it's decay, and then it's going to follow the intercept. So that's a pretty good sketch of that function. So that's a good representation of two graphing ones. You can always check these on your calculator, and you'll want to get a good idea of what these functions are going to look like based off the equation.